Hey friends, we have a new sponsor today, and I want to make sure that you support them because they make Hansel Minutes possible. RavenDB. It's a document database that's non-relational and fully transactional. It's available for Windows and Linux with official client APIs for .NET, the JVM, Go, Ruby, Node.js, and Python. RavenDB is designed for high performance, handling tens of thousands of requests even on a single node. Now, RavenDB is capable of on-the-fly optimization, dynamic indexes, and much more. It has a fully loaded GUI, which means it's simpler to operate, and you don't need, arcane incantations on the command line. It just works. It's fast and it's right. Download your free community edition at ravendb.net. That's RAVEN I hope you check it out. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Patricia Aas. She's a C++ programmer, and she's working at Vivaldi on the Vivaldi Browser. How are you?
I'm good. Thank you. How are you?
I'm feeling pretty good. I appreciate you. You're up early, and I'm up late because we're making our time zones work, and thanks for doing that.
Yeah, you too. This is really late for you.
It is a little late, but it's all good because we're talking about technology. And I'm actually running the Vivaldi browser. I discovered this a couple of weeks ago, and it's kind of like making the rounds. People are talking about it because it kind of feels like we're in a browser monoculture right now, doesn't it?
Yeah. I think we I used to work in opera in around 2005, 2009, and back then you had the browsers were more different. They were more distinct from each other. But as we've progressed, they have become more and more the same. So it's often very difficult to notice which browser you're running because they're practically identical.
Yeah, it's funny that you mentioned that. Like, even though the tabs are a different shape or whatever, you'll find yourself in Edge or Chrome, and I'll completely forget. Like, as long as the website works, I forget what browser I'm in. But then as soon as something weird happens, then I blame the browser for whatever went wrong.
Well, it becomes like you have to actually look for the icon to remember where you are. It's like, okay, I'm in Firefox now.
Well, Vivaldi, is it spiritually opera, but it's using Chromium as its rendering engine? Because it feels opera-y. It's very kind of juicy and like it moves with cool animations, and it's got bars on all four sides. It's really neat.
It's the original Opera browser, the one before the Chromium-based Opera browser, which was the one that I worked on. And this is more in that spirit of browser where you will have lots of built-in features that won't require you to install extensions for them, and lots of keyboard shortcuts, so you can very customizable, so you can make it so the way you like it. So our new slogan is "If you browse more than you sleep." So basically, it's for people who spend a lot of time in their browsers and need to customize it to their work process. But for anyone really, but it's a different kind of thing than something that you just casually pop up and surf with. It's more something that you want to control your sessions. You want to, yeah.
It feels to me like I was explaining this to a friend recently, and they wanted to know, why should I use it? And I said, well, it's kind of a prosumer, not a consumer, but like a professional consumer, because I found out that you can hit Control P, and there's a whole panel that reminds me of Quicksilver on a Mac. It's like all the hotkeys are bindable, and it's like you can type what you want instead of, if I don't know the name, if I don't know the hotkey, I can just type extensions, and it'll show me extensions and the hotkey, and then I can hit enter. So I can just like Visual Studio Code, I hit Control P and type and hit enter and move really fast. So it's very keyboard friendly.
Yeah, and that is a lot of people we used to call people power users and things like that. But I think what I realized when I was in Opera was when we were very focused on making the browser accessible in Opera in the early days. And what we saw was that a lot of the features that we added for accessibility were features that ended up being used by power users as well, because they were generally things that made it easier. to do things. You could do things with a single key, or you could do things just with the keyboards. You didn't need a mouse. A lot of those features that you could think of as power user features often end up also being accessibility features, and the other way around. It's a very interesting balance.
Well, now that Blink and the kind of the Chromium renderer thing has become a piece of the web that is now being reused, and then browsers like Vivaldi and other browsers can bring that renderer in. I've noticed that techies online have become very dismissive. Like they'll go, "Oh, that's just, skinned Chrome." And I'm pretty sure it's not, but people seem to like to say the word just.
Well, it's funny because this is a little bit of browser history, but we don't have any new browser engines. There hasn't been a new browser engine written since the 90s. So Chrome took the Chrome Blink fork was from the Safari WebKit fork, which was from the Conquer browser, which goes all the way back to the 90s. So if you want to say that somebody skinned something, then somebody skinned a browser that the KDE project made.
Oh wow!
So this is how it works. A browser engine is a very big thing, and unfortunately, we only had 4 browser families. We had the Microsoft browser family, and then you had this one, which was the Conquer KDE family, which is now like called Chromium. And then you had Opera, which had Presto. And then you had Mozilla with the Firefox Gecko kind of family. And unfortunately, Opera decided to discontinue Presto. It's still in use, actually, but it's no longer maintained. So we ended up only having 3 browser families in the world. So it's not like, so all of the browsers are based on one of those. And then, you will have further development. You will have forks, you will have things like that, but it's basically there's nothing new under the sun when it comes to browsers.
Well, it's so much heavier than it used to be. Like I'm on the same i7 that I've always had. It's a super powerful machine. It can run 90 frames per second VR, but I'm still kind of waiting for stuff to render and waiting for JavaScript to do its thing. And I'm wondering whose fault it is. And it seems just like the internet itself has become heavy. One of the things that I liked about Vivaldi is if I go to right now, I'm just going to go and type Control T and I'll type The Verge, and it's actually showing me the weight of the page in the title bar as I'm in the address bar as I load it. And it's a 1.5 meg, 2 megs of crap loading. It makes you very conscious of how big things are when you start showing up on a page and then you see right there as it loads this heaviness.
I think it's a combination of things like when one thing that the old Opera Presto was made for low end devices because it was sold to many embedded type devices. So we used to joke it could run on a toaster, and it's true. It was the most lightweight browser ever, and it was great. But it was also a big thing to maintain, and Opera decided not to. But Chromium, on the other hand, it is made for desktop browsers or desktop machines, and it's quite memory heavy. It's quite CPU heavy. No offense to anyone, but I think most people have realized that. And it's a different kind of philosophy, and I think hopefully that we are seeing that this is not something that scales. So you can't make a browser that only works on development machines. You have to make a browser that works for low end machines, and I hope that we will see more of that. I hope we will see a conscious effort to make the footprint less. But at the same time, like you said, the web has also grown, right? We are using NPM packages. We are pulling down all sorts of things we might not even need. And that's fine if you have a fixed price internet, then you don't really care about all of the megabytes or gigabytes you're downloading. But if you're paying for per megabyte, and you're downloading over a bad network somewhere in the middle of nowhere, and then this becomes a big issue. And I'm hoping that that will improve, that people have been starting to talk about how they could only load what they need when they need it, instead of just basically downloading everything.
Now, you've been doing C++ for a non-trivial amount of time. I won't give a number, but a long time, right? You've been a C++ person. That's kind of like the language of your soul. That's the one you keep coming back to?
Yeah, when I was at university, I was actually my main programming language was Java. I also did a bunch of other programming languages. My first programming language was Lisp, or a Scheme, which is a dialect of Lisp. But I did many different languages. But when I was finished at university, I wanted to work on my browser, which was Opera. So I applied for Opera, and that's when I started programming C++. So that was in 2005. So it's almost 13 years now.
Well, there's all this talk, like on the social web, about C# and Go and Java and all of these kind of like high, quote unquote, higher level languages with garbage collectors and stuff. And a lot of us like learned C++ in school and then moved on. And there's a group of us. I hope I'm not trying to be mean to your language, but kind of think of C++ as low level. Is that a fair statement to say C++ is low level?
The thing is, for me personally, I can program in many languages. I've worked professionally for 2 years as a Java programmer. I've also programmed in other languages while being a C++ developer, mainly things like JavaScript, Python, Java as well. I've never programmed in C#. Okay. But I'm very interested in learning new languages. Recently, I tried to look at Rust and Go, and I'm of the opinion that most languages have their use case, their niche, the thing that they're good at. So what C++ is good at is for cross-platform work, where you need platform integration, and also anything that it has high performance requirements, especially around memory access, where that is something that you can control really well in C++. But I do also feel that a lot of people who knew C++ before could really benefit from looking at the language again, because the type of C++ that we write now is very different from the type of C++ we wrote 20 years ago. Mm-hmm. And it is much more similar to other types of languages. Like, you could look at C++ written in like what we call modern C++, or some people are talking about postmodern C++.
Postmodern, oh wow.
But if you look at it, it will look more like other types of functional type languages, more like middle way languages like Python or JavaScript, or where you will have more functional type syntax. I mean, we have auto, we have lambdas, we have all sorts of things that make it so that you can write things in a different way than in the C type way that people wrote C++ before.
Well, because like originally, if I understand correctly, one of the original requirements for C++ was backward compatibility with C, right? It was C++, and you were supposed to make all the C programmers comfortable.
Yeah, and still, it's not a perfect containment. There are differences between the C subsection of C++ and C today. Yeah, that is mostly true, but we don't really recommend, like professional C++ programmers today don't recommend writing C in C++. We recommend using C++ constructs, especially for memory safety reasons. So if you look at modern C++, it doesn't look like C at all. And it actually makes it really, like, I am not a very good C programmer. I'm kind of a bad C programmer, because the thing is, I'm used to programming in with the C++ constructs. And the moment I end up in C, I'm like, but how do I do these things that I am used to doing in this way? So I think we're ending up in the situation where we're thinking that if you want to learn C++ today, I would recommend you not knowing C. I would recommend.
Oh, wow.
I think you'd be probably better off coming from something like a managed language like Python or maybe C# or Java, and then having a C++ programmer teach you how to do similar things. Because if you're coming from C, you are used to allocating memory in a C-like way, and that is not something that we recommend. And that becomes sort of like a hurdle you kind of have to get over to
Oh,
program
wow.
like a C++ developer. Yeah.
So that means that my, 25 years ago learning C and allocating and deleting my own memory is going to be a problem, and it's going to creep into my modern C++ code, and I'm going to forget it. It's almost like speaking old English instead of proper English.
Yeah, I have a talk which is on YouTube. It's called C++ for Java developers, and I think it's an interesting talk for anyone who's coming from a different kind of language and has like a vague understanding of Java. But one of the slides, and I say it's the most important slide, is where I have this black background and it says in green text, "Don't do this," and what it says is it allocates with new. And I was like, don't allocate with new. Try never to allocate with new. And which also means, of course, never allocate with malloc. And then suddenly I say, if you do that, if you go in and you consciously say, I'm not going to allocate anything with new, then you are in a much better place to actually try to figure out how modern C++ works, because we hardly ever use new.
Really?
Yeah.
Does that go for delete as well?
Yeah, we don't do delete either.
Who does the delete?
We use the stack to manage memory lifetimes. So you either have some kind of what we call RAI type construct, which is called resource allocation initialization, but it's basically like a smart pointer thing which will hold the object, and when it goes out of scope, it will delete it automatically. And so you will either allocate on the stack, or you will have a smart pointer on the stack, or you will transitively hold something from the stack to whatever you have on the heap, so that whenever what you have on the stack goes out of scope, everything will be automatically deleted. So we don't write delete. Like the only times you write new and delete is if you make some kind of special new containery thing. But generally you don't need to do that. So we use things like unique pointer or things that come in the standard library to do that. So you generally don't have to do I don't remember last time I wrote new, actually.
Wow. Hey folks, Intel is a sponsor this week, and I welcome them because they're bringing some high-performance developer tools for all of us. Check out Intel's Parallel Studio XE. I've talked about parallelism before on the show and the importance of using the complete instruction set, unlocking the power of the processor that your code is running on. Now, you all might be writing C or C++, Python, or even Fortran, but is your code building in such a way and written in such a way that it uses the latest techniques for vectorization, multithreading, multi-node parallelization, or memory optimization? Intel Parallel Studio XE has a lot of new stuff for 2018 across all these languages. Get a free download at bit.ly.com/parallelstudioxe, or certainly go and Google with Bing for Intel Parallel Studio XE, and get started boosting your app's performance with smart, parallel code with a lot less effort. Check them out, bit.ly.com/parallelstudioxe. Well, okay, so if everything is, if it's stack and scope based and the language is deleting for you when things go out of stacks, go out of scope, how do you keep, are you passing stuff around like a functional language, or is there a global heap? How do you have objects that have a scope that's bigger than, singletons, or scope that's program level?
You can have things that are global, but mostly we have ended up in that this is like the discussion we have in all the languages right now, I guess, that we've been having for a while since we decided that the whole singleton concept was problematic because of unit testing. So, and that's also a discussion that has been in C++ for the same reason. Like, how do you mock things out if you have globals that can be accessed from everywhere? And I guess to that end, most people have ended up with not having like globals in that way anymore.
Mm-hmm.
But you might have long living objects. So you will have maybe objects that live from the beginning of the program till the end, but they are maybe allocated very early in the process. So basically, very far down the stack, and will only go out of scope when the program exits. And then you will pass it around if you need it. But generally, I think in all languages, we're kind of moving away from having these big global singleton things.
Mm-hmm. So it's all stack, or it's mostly stack-based scope, unless you'd go and do, smart pointers, make shared and shared pointer and things like that. But why do we in the C# and the Java world love our garbage collectors so much? If this is a problem that's kind of been solved, and C++ embraces their own kind of way of doing object lifetime and resource management.
Well, I don't know if you do. Well, I was at JavaZone last year. It's a big Java conference here in Oslo, and I've been there many times because, like I said, I used to program in Java. And it was funny. I was during the 2 days or whatever the conference was. I think I was at like 5 different talks that were about memory problems. Because
wow.
And the reason why you're seeing this is something that we've seen across the industry. It is the relative cost of memory access is becoming a problem in all programming languages. The cost of accessing something that is in a register, something that is in the L1 cache, the L2 cache, and then going all the way out to memory, it can be extremely expensive. And the way that Java has traditionally allocated memory means that you will have a lot of cache misses, and memory accesses can be very expensive. But Java is also working on that. They're also working on things on how to do stack-based allocations, how to do more co-located memory allocations. And I'm sure, although I don't know C#, I'm sure that Microsoft is probably doing similar things. Because it is a problem that if you're doing a lot of memory accesses that they are not co-located, then you get cache misses all the time. You don't get any help from your L1 or your L2 caches, and that can make or break your application. Like that's 10 times, 100 times difference in performance for some applications.
Yeah, just recently in the last 6 months, I would say maybe a year, C# has started doing this thing called span of T. It's a generic that's basically lets you represent contiguous regions of arbitrary memory, but it still like looks safe, but it acts like a straight array with a pointer to like real memory.
Yeah.
And all these allocations disappear. Like all this stuff where you were copying things around just disappear. And you just, like, for parsing HTTP, rather than chopping things up, we just pointing to memory and it never moves.
Yeah. No, see? So, everyone is having to deal with this problem because the difference has become very large and it's really hitting applications, and especially for things that are memory bound. That is when the problem is. So it's funny, like generally when you see these benchmarks between programming languages, they are often very difficult to measure things because if you're CPU bound, then memory accesses won't hurt you. But if you have memory accesses, then suddenly how you access memory is a huge deal. Mm-hmm. But I think most languages are dealing with this in different kinds of ways now.
Mm-hmm. I'm reading on the web that C++ is getting a renaissance because, power is king. And while C++ and Java have like productivity benefits, you can't beat C++ when it comes down to high efficiency on like devices with limited hardware. So like, does that mean that like games and, really high perf stuff and things on small devices, it's all ultimately C++?
I think I think to a certain degree, it's become that. And I think that the whole I don't like the term Internet of Things, but basically the embedded with Wi-Fi.
Yeah, I don't think anyone likes that, by the way, that name.
But the concept of running on low end devices, I think we're getting more and more little chips that are able to run software. And what is interesting also is that what we used to have is you had a jump from really low end devices to high end devices. There wasn't a lot in between. But what you're seeing is that you're getting more of a scale where there is an actual sliding scale from really low end devices all the way to high end devices. And for the really low end devices, then C and C++ is basically all they can run. But then you're moving up a little bit, and then suddenly, you can have Python and you can have other things. And so I'm not sure. I think for high performance applications where that is a big deal and you don't have the hardware to do anything more expensive, then you're going to see a lot of C and C++. And GPU programming as well, because people are really learning how to push stuff out of their GPUs.
Yeah. Have you seen what Stephanie Hurlbert and her company is doing with their GPU image compressor?
Yeah, I only what she's been writing on Twitter and just a little bit here and there, but it looks really interesting. I think that also with regards to memory bandwidth and to performance, that's very interesting. I think you could see being able to do much more vibrant games on lower end devices with that kind of technology. So it's very interesting.
Well, speaking of perf, let's pick on a competitive browser here. I am talking to you using a podcasting application called Zencastr, and I am inside of Google Chrome. I'm sorry. And it has 61 processes running, totaling 2.3 gigabytes. And one of them is called GPU. Now, if I open up Vivaldi just in one or two pages, I'll have 9 to 10. Why do these browsers, yours included, have dozens of processes that make up some parent process, as opposed to one super everything in process for speed?
Okay, this is browser history time again.
I like that.
Okay, so let's turn back the clock to 2005, 2006, 2007. Opera was by and large one browser. Most browsers were one process. Most browsers were one process. Mm-hmm. Opera on Linux had a separate plugin process where we were running plugins in a separate process. But we were running them in process on Mac and Windows, and all other browsers were doing the same. And then Google decided to make a new browser. It's called Chrome, which was funny because it didn't have any Chrome. That was a thing. Because that was the thing when Google came out, it didn't have any window Chrome, but they called it Chrome. Anyway, but it was a very very simple UI, very very clean, very interesting. But what they needed was an engine for this, and before Apple had forked the KDE Conqueror type project and created this thing called WebKit, which they used to make the Safari browser. And Google looked around and decided that this was probably the best thing, to use WebKit as their engine for their new browser. But this was basically an in-house project in Apple. But they were doing source code dumps every night. Now, this is how I remember it. So if somebody remembers it differently, please tell me, because this is how I remember it from at the time. And so Apple was doing source code dumps every night, and Google had to pick it up, and there was no revision history. And this was kind of problematic because WebKit was unstable, and it was very difficult for Google to control quality. So they made a framework around WebKit where they put WebKit in its own process, and they made a separate browser process to manage all of these WebKit processes. And they call these WebKit processes for renderers. So and then they had one per tab. And then they've pitched this as a feature for Chrome that, a tab can crash, but it won't crash the browser. But basically, it was because they were incorporating an engine that was very unstable.
I was going to say, like, hey, look, a tab can crash and the whole world doesn't crash. Like, why are tabs crashing?
Well, it was an architectural solution to a real world problem, and it was kind of an interesting solution as well, because suddenly now you have all of these separate processes that are rendering things, and then you have the browser process that is the one that is responsible for the global kind of state, and then you still have to compose all of these images together into one thing and put it on the screen. And so in the beginning, if I remember correctly, everything was software rendered. So everything was done in the browser process. So basically, they would just send pix maps all to the browser, and the browser would compose it all to one big window. And that's what you saw on the screen. But after a while, you want to do this with the GPU. And what they got as a side effect of this architecture, of course, is that they could use platform primitives to set up individual sandboxing environments for each type of process. And they did that. And so you have a very strict sandbox for the renderer process. So for example, on Linux, it cannot access network. It cannot access the platform file system at all. It's basically living in a world where it can only see itself as a process. It's using a lot of Linux APIs to basically isolate the renderer a lot. And this is a good thing, because JavaScript is executing on your machine. I make a joke sometimes that remote code execution is our business model. That's what we do.
Pretty much. That is the definition of a browser.
Yeah. We download random code from the internet and execute it on your machine. So having that in some kind of sandbox environment is in general a very good idea. So they did that. So they ended up having very different kinds of sandboxing for the different kinds of processes. And then if you're going to pull in a GPU driver and a graphics framework, then this is going to require gaping hole in your sandbox. So basically, then you put it in a separate process where it has a more permissive sandbox than your renders, and then you try to figure out how that's going to work. And that's a whole other architecture they made on top of it again, which is very interesting, which I made another talk about.
And so this is great. So you're going to give me a whole bunch of great links that I'm going to point everyone to, because I think we could probably go on for an hour, but we're out of time. Where can people look at these? I went and Googled for your name and found a ton of great talks you've given on GPU, on security in C++, on modern C++. These are all available on video, and have you spoken at a ton of conferences like NDC?
Yeah. I had a bunch that are on YouTube, some that are on Vimeo, and so you Google my name, you can generally find videos.
Mm-hmm. And you're working on Vivaldi now for the company full time. Is a startup, would we call it?
Yeah, I guess you can call it a startup. It's privately owned. So it's owned by Jon, one of the founders of Opera. He owns Vivaldi, and he is funding it. So it's from his
pocket.
His pocket, yeah.
Great. Well, people should check it out. It's Vivaldi, Vivaldi.com. It's super fast on Windows, and it's really attractive. It's a very attractive browser. The history page is almost worthwhile using that. Like, history on Chrome is just a list. but History and Vivaldi has statistics and browsing activity and what kind of links you click on and a calendar view and a month view. It's really, really interesting. And it's disturbingly customizable. There's 11 ways to do stuff, and I can move the tabs to the top, the bottom, the left, the right, any way you want it to look. It can be skinned lots of different ways. And then also tab tiling and stacking, which is something you don't see anymore as well. It's not Chrome at all, but it's pretty cool.
I'm glad you like it.
Yeah, I'm having a lot of fun with it. I think it's great that there's, there's Edge, there's Firefox, and there's Chrome, and I think they're all browsers worth checking out. But there's also Brave, and there's Vivaldi, and suddenly we've got a 5 to 6 browser race here, and it's a lot of fun to try these new browsers. And if you find one that feels good, that has the features that you want, you should talk to people about it. And I appreciate you talking to me.
Thank you.
This has been another episode of Hansel Minutes, and we'll see you again next week.